Alright, so the purpose of this video is just to kind of get an understanding for linear equations in what we call standard form. Alright, and this is actually a file that I use for my students. And so we're just going to look at the uses of standard form, why it can be useful, and how we can actually apply standard form to a graph. And so we're just going to start, I want to start with a word problem because this kind of shows the intuition behind using standard form, not just what it looks like graphically, but how you can actually use it in the real world. So let's look at this first question. This says Hannah will spend $150 on music festival tickets. Now, reserved seat tickets cost $25 and general admission tickets cost $10. How can we represent this situation with a linear equation? Well, let's first organize our information. Now, Hannah wants to spend a total of $150. That's what she's willing to spend. Now, there are two different types of tickets she could buy. She could buy reserved tickets or reserved seats for more expensive for $25, or she can get general admission tickets for $10. Now, since those are two different products or two different things to buy, those cannot be represented with the same variable. So let's go ahead and say, well, the reserved seat tickets for $25 will be assigned the variable x. Okay, so those are the reserved seat tickets. And then the other one, the general admission, we can use a y for. So y is going to be the general admission tickets. All right, now we can go ahead and build an equation. Now, the x and the y, like we said, are going to stand for how many, like the number of tickets you can buy for each of these. And then $150 is how much Hannah's willing to spend. So let's go ahead and build a linear equation based off of this. Well, I'll go ahead and start with my reserved seat tickets. Now, the cost of those is $25, and we'll include the x for the number of tickets that she could purchase. Okay, now that is going to be added to $10 per general admission ticket. Okay, so on the left side of this equation is going to be everything that adds up to the total value, and on the right side equals how much she's willing to spend. So like the other two forms of linear equations, like slope-intercept form and point-slope form, we have an x and we have a y. We also have this constant, and we'll talk about how all these are related to slope-intercept form here in just a moment. But I want us to look at this equation before we move on. This says $25 per reserved seat ticket plus $10 per general admission ticket equals a total of $150. Now, the reason that's useful is, let's say, okay, Hannah wants to buy 3 reserved seat tickets. After she buys 3 reserved seat tickets, how many general admission tickets can she buy after that? Well, all you would have to do is plug a 3 in for x and then solve for y, and that will tell you how many tickets she can buy for general admission. So we could say 25 times 3 plus 10y equals 150. And now that gives us an equation to solve, and when we solve that, we'll know how many general admission tickets Hannah can buy. Okay, now 25 times 3 is 75. So 75 plus 10y equals 150. Okay, we'll subtract 75 from both sides. We'll get 10y equals 75. And then lastly, we'll just divide by 10. And when we do that, we get y equals 7.5. Now, we can't really buy half of a ticket, so what that means is Hannah can buy 7 general admission tickets after purchasing 3 reserved seat tickets. So that's why standard form can be useful when talking about real life situations. So let me clear this up, and we're going to go ahead and move on to what standard form is written as. Now, if you'll notice in this equation up here that we wrote, this is in standard form. So the general equation for standard form is going to be ax plus by equals c. All right, and you'll notice up here that our a and b value are whole numbers. So let's talk about this for just a second. Okay, so this a is going to be the coefficient or the number in front of your x value. So in this given equation, 25 is the a value, and 10 is the b value, because b is just going to be the coefficient in front of y. And then c is our constant. So 150, that is our c. All right, so how can you graph in standard form? Well, let's take a look. Okay, it says graph this equation. It says 2x plus 4y equals 12. Well, how do we know that's in standard form? Well, there's a couple things. The x and the y are on the same side, okay, just like in this general form. And also our a and b value, okay, our a value and our b value, those are both whole numbers. Now, the easiest form to graph in tends to be slope-intercept form. So if you remember, slope-intercept form is y equals mx plus b, okay, where m is your slope and b is your y-intercept. Okay, so the easiest thing to do is going to be to convert this equation into slope-intercept form. The way to do that is to isolate your y variable, get that by itself. So to do that, it only takes 2 steps typically. I will subtract 2x because I want to move my x variable to the right side. Now when we do that, those will zero out or cancel out, and I'll go ahead and rewrite. I have 4y on the left side equals. Now, it's tempting to write 4y equals 12 minus 2x. However, let's put the x value first, because if we're converting this to slope-intercept form, we need that x value to be the first value on the right side of the equation, because that's going to be our slope. So negative 2x plus 12 will be a better way to write this. Now, lastly, I'm going to divide everything by 4. Okay, now remember, we divide this side by 4 to get the y by itself. However, we're dividing this side by 4 because in an equation, if you do one thing to your left side, you have to do it to your other side, or vice versa. And the reason we do that is because of this equal sign. If you manipulate one side of the equation, you have to manipulate the other in the same way to keep that equality. All right, so we get y equals. Now, we know negative 2 divided by 4 is negative 0.5. However, this is going to be our slope in our equation, so let's leave it as a fraction. So I will simplify it though. It'll be negative 1/2 x plus 3, because 12 divided by 4 is 3. Now, this is an equation we can graph now, because that's in slope-intercept form. My slope is negative 1/2, negative 1 over 2, and my y-intercept is 3. So to graph this, all we have to do is go to the 3. Okay, that's my y-intercept. And now my slope is negative 1 over 2, so I'm going to go down 1 over 2. And now you only need 2 points to make an accurate graph, but if I really want to be specific and precise on my points, all I have to do is continue following the same slope the entire time, and I can get a very accurate line. Okay, now the line I connected all these with isn't great. However, the points are the important part. So that is how we would graph the equation we started with over here. This equation right here is this graph. All right, so what I'm kind of hoping we see is that standard form can very easily be converted into slope-intercept form. So kind of as an important note, we can say that to graph a line in standard form, you must convert into slope-intercept form. So before you can really start graphing with standard form, you have to understand slope-intercept form. So make sure you understand that before you start looking at standard form. Because slope-intercept form is kind of like, it's kind of almost like home base for all these linear equations. So now we're going to do a couple examples of just converting standard form into slope-intercept form. Now, notice the x and the y are on the same side, and the coefficient values, the a and the b, those are both whole numbers. All right, so step number 1, like we did earlier, I'm going to move my x value, so I will subtract 3x from both sides. So this will cancel out here. Now when you rewrite, make sure you're going to bring down this, it's now a negative sign in front of your 2y, so it's going to be negative 2y equals negative 3x, because remember we're going to put that x value first, negative 3x plus 6. And it's going to be a plus 6 here because the 6 up here in the equation is positive. And, that might sound redundant for me to say, but that is a big mistake I notice sometimes is when students take these equations and rewrite them. Like, well, we subtracted 3x here, maybe it's also going to be a minus 6. That won't be the case. Okay, this 6 up here is positive, so we will add 6 in the equation. All right, now lastly, I will have to divide to get rid of my coefficient in front of my y, which I will divide by negative 2. Negative 2. All right, so we get y equals. Now, again, like we talked about, this is going to be our slope. So negative 3 over negative 2. Yes, it does divide to become positive 1/2, or positive 1.5 rather, sorry. However, we don't want to do that. We want to leave it as a fraction. So the only thing we'll do to simplify is knock these negatives out, because a fraction means division. It symbolizes division. So if you have a negative on top and bottom, a negative divided by a negative is going to be positive. So instead of negative 3 over negative 2, we'll put just 3 over 2, x. Now this is going to be minus 3, because positive 6 divided by negative 2 gives you a negative. Now, we don't have graphs to graph this on, but if I were just to kind of estimate it, my y-intercept is negative 3, and my slope is up 3 over 2. So if I were to just kind of estimate a line, very, very rough sketch would look something like this. Okay, so let's move on to the next one. Now this one, go ahead and give it a try yourself. You can pause the video and then unpause it when you've given it a try. Okay, so for this one, if you notice, there's not really a coefficient with the y. I mean, technically there is a 1 there. However, there is no expressed coefficient, meaning we're not going to have to divide it all in this one. All we have to do actually is just move the x value over by subtracting 4x. When we do that, the left side will have y left. Y equals negative 4x plus 8. And that is already ready to graph, because if you notice, the y is already isolated now, and we have our slope and we have our y-intercept. So again, if I were to estimate a graph, well, the y-intercept is 8, put it way up here. Then with a slope of negative 4 over 1, it'd be something like this. Slope might be a little bit steeper. I might have gone a little bit too far over, but that's just a very rough estimate. And last one on this page. Go ahead and pause the video, give it a try. All right, so I will move my x value. Okay, remember, bring down your negative. So it is negative 5y equals negative 3x minus 25. So lots of negatives going on here, but as you're about to see, the whole thing's about to become positive because we have to divide by a negative 5. Because that's the coefficient in front of y. Now that's going to give us y equals, now negative 3 over negative 5, for one thing, it's going to become positive, but we're not going to change it to 0.6, so we're going to leave it as a fraction. So it's going to be y equals 3 over 5x plus 5. Okay. And then again, I know I keep estimating them. It's just a good skill to be able to just like visualize what this graph might look like. So y-intercept at something like 5, and then if I go up 3 over 5, maybe something like this. Again, very, very rough estimate, but just something like that. Okay, so let's add earlier right here. Okay, 3x minus 5y equals negative 25. That was that same equation. Continue on. Now we're going to do 2 more examples of how to convert these, and then we're actually going to put these on a graph. So if you're using the PDF at home that I attached in the description of this video, which I guess I never said that. Yeah, in the description, there is a PDF file of this that I'm going through. So if you want to print that off, if you have access to a printer, you can do this work at home with me. So subtract 4x, subtract 4x. We get 5y equals negative 4x plus 10. Now I like to teach people to look out for patterns. If your equation you're starting with, if the standard form you're starting with, if everything is positive, or rather really, if your x value is positive over here, you're going to end up with a negative slope in your final answer. So just a thing to look out for. So then just divide everything by 5. we get y equals negative 4/5 x plus 2. So we notice we have that negative slope like we said. It's because when it's positive over here, when you move the x value to the right side, it has to become negative. So fairly straightforward equation to graph. Now before we do b, let's go ahead and graph this one. So we have a y-intercept at 2. Okay, I'm going to zoom in real quick. And the slope was negative 4/5. So y-intercept of 2. Then go down 1, 2, 3, 4 over 5. Just like that. Go down 1, 2, 3, 4 over 5 again. There it is. Now I like a good accurate graph, so I'm going to fill out the other way also. 2, 3, 4 over 5. All right. And then my last point would be about right here. Alrighty, now there's the first one. Alright, now the second one. Now what are we noticing about this one? Well, I do not see an x value. Does that mean it's not a linear equation though? So no, it still is a linear equation. Let's just see what we have to do. Now we said the first step to convert this to slope-intercept form is to move the x value, but if there is no x value, we're going to skip that step, and we're simply just going to divide both sides by 8. All right, when we do that, we get y equals, well, 32 over 8 is 4. So that's our linear equation, y equals 4. Now, what I like to show students is, if you're confused about what that means, go ahead and write out your general equation for slope-intercept form and see, what are we missing? Well, we have y, and this is a constant, so we have b, which is our y-intercept, but what we do not have in this equation right here is our slope. Now, that just means there's a slope of 0. It doesn't mean that the line doesn't exist. It doesn't mean any of that. What it's going to give you actually is a perfectly horizontal line. Okay, so if the y-intercept is at 4, I'll put my point at 4, and if there's no slope, okay, just kind of think of it as a flat surface, like the floor you're standing on or whatever it is. It is a flat surface. It is a horizontal line. Okay, no slope whatsoever. So in a linear equation, if you ever just get y equals a constant value, then it's going to be a horizontal line at whatever that value is. Because if you think about it, no matter where you go on this line, it is always matching 4 right there on the y value. If I go over here, this point is negative 9, 4. Okay, it is still 4 in the y value. Okay, kind of think of it as keeping a consistent elevation the entire time. Alright, so the last thing I wanted to look at is converting from slope-intercept form into standard form. Okay, and again, it's pretty simple. Now remember, standard form is ax plus by equals c. And then, again, the big stipulation is that a and b have to be whole numbers. Okay, we don't want fractions. Okay, they got to be whole numbers. And they also have to be together on the left side, essentially. So let's look at the first one. Okay, letter A. Y equals negative 4x plus 8. Well, I want to move my x back over to this side. So what do? Well, we're just going to add 4x to both sides. Okay, now we want it to lead with the x value. So it's going to be 4x plus y, because that's a positive y, that equals 8. Now let's ask ourselves, is this in standard form now? Yeah, because we have our a value. Okay, well, first we have x and y, and then we have our constant value, and our a value is 4. Our b value is 1, because when you have a variable by itself like that, its coefficient value is going to be 1. All right, so we're good on that. Now let's go to b. Y equals 3/5 x plus 5. Now, we notice we're going to have to move the x over, and also, this is not a whole number, so we're going to have to do something about that. But first, let's just go ahead and move the x value. So I'm going to subtract 3/5 x from both sides. And I'm doing it on the right side so I can get rid of it on the right side, and you do it to the left side to keep that equality. So we'll get negative 3/5 x plus y equals 5. All right, Now, there's one more stipulation that I really didn't have a chance to say until now, but as we talked about, we can't leave this as a fraction. This has to become a whole number coefficient, and also a cannot be negative. Okay, remember, a is the number or the coefficient value for x. It cannot be negative. So at the same time that we get rid of the fraction, we have to get rid of the negative sign too. And how can we do that? Well, we can multiply, we can pretty much just multiply everything by the denominator. Okay, if you want to get rid of a fraction, multiply by the denominator. We can't multiply by the reciprocal. The reciprocal would be 5/3. And if we do that, multiplying y by 5/3 would give you 5/3 y, thus giving you a fraction for y. And again, we can't have that for the b value. We can't have a fraction for the b value. So the number, or the coefficient in front of x and y both have to be whole numbers. So we're going to multiply the whole equation by -5. Now, we're multiplying it by 5 to get rid of the fraction in front of our x value, and we're multiplying by -5 specifically because we have to get rid of that negative value also. So multiply by -5. Now, what that's going to give us is 3x, because the negatives will cancel, and the 5's will cancel. So 3x, okay. Now, -5 times y is going to be -5y, so 3x minus 5y equals -25. All right, and actually, if you notice, that is the same equation. All right, so let's do the last one now. Now, this one is in kind of a crazy order. This is 8 plus 3x equals -9y. So again, we want it to look like this. ax plus by equals c. That's what we want it to look like. So I'm going to say we need the constant to go over here. All right, we need the y to come over here. Now, all these are the a value and the b value, those are whole numbers, so that's good. We don't have to multiply or divide by anything. We just want to get these where they belong. So we can really just do that in one step. If I need to move my constant, I'm going to subtract 8 on both sides. And then if I want to move my y value, I'm going to add 9y to both sides. And then I'll just write it in the order that it falls. So on the left side, the 8's cancel out. I have 3x. And now I added 9y, so I get 3x plus 9y equals, well, these 9y's cancel out, and we have -8 left over here. So 3x plus 9y equals -8. All right, so this is a video over standard form and pretty much essentially how it can be used in a word problem. Now there's one word problem down here that we did not go over. However, if you want to give it a try if you were able to print it out or access the PDF file from the description, then go ahead and do that. I'll post the correct answer to it in the comments. And yeah, with that being said, that is just kind of a basic rundown or introduction to standard form of linear equations.